Okay, today we're going to be talking about heat transfer. We've been going over this the last few days in class. We've talked about radiation. Now we're going to focus a little bit more on conduction. Here's some of the vocab words that we have. Absorb, conduction, differential heating, energy transfer, heat, infrared, kinetic energy, radiation, radiant energy, rays, and waves. I also put a couple statements here at the end that I want to make sure that we all understand. Okay, it takes 5 times more heat energy to raise the temperature of water than it does dry soil or sand 1 degree when you have the same amount of each. So I want to make sure that we know that water being denser is not going to heat up as fast as sand or soil. The other thing here is, this is an important one, heat is always going to flow from the warmer object to the colder object until they reach the same temperature. That's a very, very important one to remember. And again, once they reach the same temperature, then heat is no longer going to transfer. Some of the things that we looked at in class, we did a little lab, and this diagram that I have here is going to explain kind of what we did in the lab, and it breaks it down on a very, very simple scale here with the molecules, so we can actually see what's taking place with conduction and as energy transfers from one object to another. So as we start heating things up, okay, we can see the energy in the water is going to receive the heat from the heating coil, and the water molecules are going to increase their motion or increase their heat and start to move faster. They have more energy. Because they have more energy, they're going to start to bump into the glass molecules, causing the glass molecules to vibrate or quiver a little bit faster. So the faster moving molecules hit the glass thermometer bulb. Energy from the water transfers to the molecules in the glass thermometer bulb, and the glass molecules start to move faster. Now they are, as a glass, a solid, so they're not going to be able to move around freely like we see with the liquids. They are going to stay in place, but they are going to wiggle or vibrate faster when they do get heated up. Okay, we can see the alcohol rising up the stem there. So as that vibrating glass molecules hit the alcohol molecules inside the thermometer bulb, the energy is going to transfer to the alcohol molecules. The alcohol molecules move faster, and the alcohol expands and moves up the stem, kind of like we talked about if we were going to try to play dodgeball. Okay, we wouldn't be able to do it very well in the classroom because it's too small inside the classroom. We'd be bumping in and knocking things over. So we'd have to move to a bigger area. Because we're more energetic and we're going to be moving around more, we need a place like the gymnasium to be able to handle that extra energy that we have and that extra amount of movement and energy. As we start to cool things down, we could see that the water is going to then not be as energetic and not move around as much. When the heat is turned off, energy radiates from the water to the environment. The water molecules have less energy and move more slowly. Next, the glass molecules are going to transfer their energy to the cooler water. The glass molecules have less energy and move more slowly. And finally, we're going to see the temperature start to drop and the alcohol goes back down the stem. The alcohol molecules are going to transfer their energy to the cooler glass, which will then transfer to the water. And the alcohol molecules have less energy and move more slowly. The alcohol contracts and moves down the thermometer stem. And like I said, that's kind of more of sitting in the classroom, not moving around, not a lot of activity, not a lot of energy. We're able to be in a smaller space because we're not as energetic, not moving around as much. So we have that decrease in energy, and we see then the thermometer reads a decrease in heat or temperature. One of the next things that we did was we read an article about thermometers. It talked about the different types of thermometers. It talked about the glass thermometers filled with alcohol or mercury. It also talked about development of the temperature scales with Fahrenheit and with Celsius, different types of thermometers, bimetallic strips, liquid crystal thermometers that we would see a lot of times on fish tanks, digital thermometers that we would use for checking our temperature at the doctors in a lot of cases. Also, decorative thermometers like we see here with the Galileo thermometer with water in it and balls at different buoyancies that would float with different weights on them because of the density of water and how water changes its density as it increases and decreases its temperature. One of the other things we did then was a worksheet where we looked at what the definition of heat is. Okay, and we have heat is the kinetic motion of molecules. Again, kinetic energy is energy moving energy. That's why I have here kinetic energy or kinetic motion. So as those molecules start to move around, the more they move around, the more heat there is. And that's whether it's a solid, liquid, or gas. And like we talked about in class, if we start getting something very, very excited, it is no longer going to stay in its position. It's going to need more space. It's going to need to move around more. If we have a pot of boiling water and we get it heated up enough, eventually we're going to get steam coming out of that, where that liquid molecule or the water molecules are no longer going to stay in that liquid state, and they're going to become a gas, and they need more space. They're going to be more energetic and be able to float around in the air. Next, we looked at describing heat in terms of conduction. Heat conduction occurs when two molecules touch each other. It's kind of our definition of what conduction is, and then it gives a little bit of explanation of how conduction actually works. The motion of atoms and molecules in water and materials transfer to the atoms and molecules in the colder material, making those molecules move faster. That increase in motion will give us an increase in heat and an increase in energy. The third question here, explain your understanding of how heat transfers from one material to another. Again, we've been talking about two types of heat transfer. So the first thing here is materials can absorb radiant energy or light, infrared, or ultraviolet rays of energy from a radiant source like the sun. And that's our best example of radiation or radiant energy is the sun. That energy gets absorbed. As it gets absorbed, we see an increase in molecular activity, more movement in the molecules. The other type, what we've been talking about with the lab and more so in this video, is when molecules touch. The motion of an atom and a molecule in the warmer material is transferred to the atoms and molecules of the cooler material, making those atoms and molecules move faster or increase their energy and temperature. And this is called conduction. The last question, and I really like these questions, especially this last question, very practical application of how heat transfers. So explain why the soda can feels cold when you take it out of the refrigerator. The atoms or molecules in the soda can have less energy or less motion than the atoms or molecules in your hand. Heat transfers from your hand to the soda by conduction. The molecules in your hand lose energy and move more slowly. Your hand senses this loss of heat or loss of energy as cold. Anytime your body is going to transfer energy away, it's going to get that sensation of being cold. Like we talked about in class, if we went outside without a jacket on, we would be transferring energy to the air around us, and we'd get the sensation of being cold. Doing that long enough would be very, very bad and lead to things like hypothermia and frostbite, because our bodies are not going to be able to transfer enough energy away to heat up the atmosphere around us, and it's going to keep trying to do that, but it's not going to be able to do that. On the flip side, anytime our bodies absorb energy, we would get the sensation of being warm or feeling that something is warm. So if energy is going to transfer to our bodies, that object that's going to transfer that energy to our bodies is going to feel warm to us. Okay, especially if it's through conduction. When we touch something that is hot or hotter than our hand, energy is going to transfer to our bodies from the warmer object to our cooler hand until they reach the same temperatures, and that's where we're going to feel that something is warm. So the opposite of what we've seen here. Again, remember that there is no such thing as cold. When we're talking about things being colder, we're saying that they have less energy or a lower temperature. And remember that temperature is a measure of the energy that something has. So something has less energy, it's going to have a lower temperature. It's not going to have as much kinetic energy or as much motion in its particles. When something is reaching a high temperature, it's going to have more kinetic energy or more motion in its particles, an increase in energy, an increase in heat, and we're going to say that it has a higher temperature. One of the last things that we did was we looked at another article in the book, Heating Up the Atmosphere. This article does a very, very good job of recapping all of the things that we've talked about. Heat and movement, heat transfer, goes over radiation and light, and we talked about with light how we see things, how we see colors by light reflecting off of objects. Okay, it also goes over conduction, has a nice little diagram here of particles colliding, and when that contact takes place, that's the energy transferring. And then the high energy particle does not have as much energy after the contact has taken place. The low energy particle now has more energy than it started with, and both then end up with the same amount of energy. Also does a nice job of talking about heat and how it transfers through the atmosphere. Okay, as we're looking at heat transferring by the atmosphere is heated by radiation from the sun, solar energy. Lots of different kinds of rays are sent out by the sun. It's important that the ones are visible light, and infrared radiation. It seems pretty straightforward. Unfortunately, it's not as straightforward as it seems. Okay, the air is 99% oxygen and nitrogen molecules. Neither of those types of molecules absorb visible light or infrared radiation. It just doesn't happen. The only water vapor and carbon dioxide absorb significant amounts of radiant energy, and mostly infrared rays and not visible light. It goes on to talk about here how only a tiny part of the atmosphere gets heat from incoming solar energy. So how does the rest of the atmosphere get hot? Visible light is absorbed by the Earth's surface. The land and seas warm up. The air molecules that come into contact with the warm land and water molecules gain energy by conduction. Okay, and it also goes into re-radiation, which is an important thing. Okay, this is when the Earth actually gives off infrared radiation that can be absorbed by water molecules and some carbon dioxide molecules to the atmosphere. The energy is absorbed in small numbers by the water molecules and transferred throughout the atmosphere by conduction when hot water molecules bang into oxygen and nitrogen molecules. The atmosphere is not heated from above, but it's heated from below, and that's an important thing. And they have a little diagram with this. The sun is shining down the energy to the surface of the Earth. The Earth is warmed by the solar energy, and it re-radiates that infrared radiation. Okay, the air molecules are warmed by conduction at the surface, bumping into the land and the water. The water molecules are warmed up by radiation coming up from the surface of the Earth. And again, those water molecules are going to bump into other molecules in the atmosphere, and through that contact, they're going to warm them up. The article also goes on to talk about thermometers again and how thermometers work, and it goes through conduction with molecules bumping into the glass and affecting the alcohol inside, and it goes over some of the different things that we talked about with that diagram from earlier. And it went over some of the nice questions here. What is heat as a review? Okay. What heats Earth's atmosphere? That's a very, very good question. I really like that question, and I would definitely expect you to know that question for the test. Okay. What are two ways energy can transfer from one material to another? Again, talking about the different types of radiation and conduction. Explain two ways Earth's atmosphere gets heated up. That goes right back with question 2. So questions 2 and 4 are very, very good questions that will definitely be on the test. I would make sure I know those questions. How the energy is sent down to the surface of the Earth and then is re-radiated back into the atmosphere, and through conduction heats the atmosphere. Okay, what do thermometers do? What is temperature? Explain why alcohol levels in a thermometer go down when the weather gets cold. And we talked about, expansion and contraction. When things get hot, they expand. When things get cool, they contract. So that pretty much is a wrap-up and review of not only conduction, but heat transfer. We're going to have our test. If you have any questions, feel free to stop by in class and make sure to ask.